Good morning. My name is Caden Ratturi, and I am an enterprise architect focused on data privacy and AI, and I'm here to talk to you about guardrail drift. Almost every enterprise is building their AI strategy around frontier cloud APIs from providers like OpenAI, Anthropic, or Google. And we treat the APIs like traditional software dependencies, where we pin a version number and we assume that if our code doesn't change, the system's behavior won't change. I'm here to tell you that that assumption is completely false. Cloud LLMs are not static binaries. They are living, breathing, dynamical systems, and the very mechanisms that make them safe for the public make them fundamentally unstable for your critical internal operations. I call this the guardrail drift hypothesis. Let's look at the physics of how this works. An LLM operates in a high dimensional semantic space. Every time a cloud provider discovers a new jailbreak or faces a new liability threat, they deploy back-end safety patches. They tweak the reinforcement learning, update classifiers, or silently inject system prompts. Think of it like a traction control system in your car. Every update changes how the vehicle handles. Your prompts still technically execute, but the trajectory through the semantic space is shifted. Suddenly, your carefully tuned classification boundary moves. Your extraction prompt starts refusing to output certain formats, but you didn't do anything wrong. The road moved underneath you. Now, to be clear, for certain workloads, guardrail drift is a feature, not a bug. If you're building a public facing customer support bot or a marketing copy generator, you want the cloud provider constantly updating their safety filters. We can use this as an external safety zone where we trade strict determinism for a liability shield. The vendor absorbs the risk of the latest prompt injection attacks, and if the chatbot slightly changes its tone, it's not a crisis, it protects your brand. The risk profile completely inverts when we talk about internal mission critical workflows. When you're talking about enriching your healthcare data, algorithmic trading, financial compliance, automated QA, any kind of regulated workflow requires strict determinism, bulletproof audit trails, and semantic stability. If an API safety classifier suddenly flags your medical rag pipeline is sensitive and truncates the reasoning steps, your automated process fails silently. You can't build reliable enterprise architecture on shifting ground. You would never accept a SQL database that changed how it interpreted SQL queries overnight, and you can't accept that for your enterprise AI. The solution is to bring the cognition in-house using open weights models. If you take an open weights models and deploy it on your own infrastructure with your own harness, you own the weights and the control plane. You freeze the semantic baseline. The vendor can't patch your safety layers, and no one can change your prompt routing. You regain reproducibility and auditability, so your clinical or financial pipeline will process data the same way today and 6 months from now. However, that does mean that you have to take ownership of what the cloud vendor does. You have to build harness engineering practices, an operational environment, including memory, guardrails, and tools around the model, and especially a rigorous continuous evaluation stack. You need automated benchmarks and an LLM as judge pipelines that run on every commit, because when you do decide to upgrade that internal model, you need mathematical proof that your semantic baseline hasn't regressed. AI maturity isn't about choosing cloud versus on prem, open weights versus frontier models. It's about a hybrid architecture where you route your public risk to the cloud and anchor your critical internal reasoning on open weights that you control.